So we're going to talk about the asterisk. So we can say echo asterisk, for example. And if we do that echo and then the star or asterisk, what that is going to do, it's going to show everything, because the asterisk literally matches everything. So if you just do an ls, this is the home directory, and this is everything below, within or containerized in the home directory. So for example, if I said ls downloads, it's going to show me all of the files in downloads. If I echo downloads and then I use the asterisk, of course, again, it's going to show downloads, and then it's going to again match everything on my local level, if you will. So let's take a look at doing something a bit. Let's filter everything, and let's only show the downloads file, and let's only show what would happen if we just did myfile1.txt. So we're going to do asterisk, which matches everything before, and then the number 1, and then the asterisk again. So it will only match against this file right here. If I press return, it only matches with this file right here. We can do the same thing with the number 2, and it only matches against this file. So you can see the power, if you will, of the asterisk character. All right, let's check out the grep command. What we're going to do is we're going to do ls downloads first, and then we can see that we have myfile1 and myfile2. Let's go ahead and create myfile3 from this position. We're going to say touch, or actually we want to say sudo touch, and then we'll say downloads, and then myfile3, because sometimes it's best to stay where your current prompt is. We don't want to be crawling, in our file system if we don't have to. So we'll just be safe and just create the file with the touch command in our current position. We'll press enter, and then we can verify that has been created, myfile3. Let's go ahead and put things in it. So we'll say sudo vim myfile, and I'm going to press tab, and it does not autocomplete because nothing seems to work when you want to. Oh, you know what? That's why. So we're going to say downloads, and then my file, and then 3, and then we'll press tab again for autocomplete, and we're going to press I for insert. We'll just simply put some various things in here. We'll say dog, dogs, cat, rhino, just to put some different things in there, some different phrases or nouns, if you will, or objects. We're going to say :WQ to write this file, and we can actually stream it. So instead of saying downloads myfile3.txt, we'll just say cat, and we can see everything that we want to. But what if we could use the grep command to filter only certain things? And you can imagine what the uses are. So we'll say grep, and we're asking it what do we want to match against, and we'll match against anywhere in the file it says the word dog, so it should match both dog and dogs. But where do we want to match it? We'll say downloads myfile3.txt, and we can see that it matches both dog and dogs. Now, if, for example, we just wanted it to match the letter C, it only matches cat, and the letter R, it matches rhino. So that is the grep command in a nutshell. Begin the talk about the less program or command, I want to talk to you about the absolute versus relative path. An example of an absolute path is when here we're catting, or we are going to be streaming this file called words, and here is the path. /user, I don't know if you call that a front slash, we'll call it /user share dict or dictionary, and we're asking it to list all the contents of the words file here. So for example, if we said, let's just go back here and we just did to list the contents of the dict directory or dict directory, we can see that we have American English, which is a file, and then readme select word list, which is also, I should say American English is a directory, readme select word list is a directory, and these would be files because they're in blue. So we can actually stream words because it is a file. And in terms of what type of path this is what we call an absolute path. This means that it is preceded by the slash and can be used anywhere in your file system directory. And of course, that is the stream of the file. You can see that that includes like a lot of different words, and it keeps a track of all those words for things like parsing files and things like that. So now we can use relative file pathing if we're like maybe below our current directory that we want to get to. So a relative path is when we can say ls and then downloads, and then this gives us the entire directory of our downloads. You see how I didn't need the preceding slash? That's because it's a relative path. So if I decide to make another directory, make dir downloads, and the directory I wanted to make was my dir, and I could say, for example, ls downloads, and then my dir, and there's nothing in there. Now if I said touch downloads my dir, and then I said my file 44, called it that. Oh, you know what? I had a misspell right there. I should not be typing so fast. So there's my file. So again, if I said ls touch downloads my dir, we have my file 44. So you can see this is a relative path because we did not need the preceding front slash. And the reason why we can use a relative path in this case is because we are right next to it. We're currently adjacent to that class. But something like this, which is way up ahead of us, way up, it's higher than us, we will need to use the absolute path. And again, the whole point of this is if we stream using cat, we see a large amount of output right here. But if we do the same command using the keyword less, and then we press enter, we can see that it only shows us a small portion of it, and then we can press the space bar and it shows the rest of it, and we can navigate it a lot easier because we can just proceed and go forward with the space bar. And if we wanted to go up, we can use the up arrow and we can use the down arrow for down, and it's just easier to navigate with the less command. To get out of here, we press quit, but that is the command right there, less. Okay, so let's list what's in my downloads file, and we have the directory my dir, and we have these files, my file 2 and my file 3. Let's go ahead and let's download let's list what's in my dir, and we only have my file 44. So let's go ahead and put my file 2 and my file 3 into my dir. So we're going to use the move command, and then we're going to utilize my downloads. From downloads, and we're going to move downloads my file 2.txt to downloads my dir, And then we're going to do the same thing for 3 and enter. So let's go ahead and let's look at what's in my dir, and that is my file 2 and my file 3. If we streamed my file downloads my file 3, and it's my dir, my file 3, we have dog, dogs, cat, and rhino. If we did the same thing to 2, I don't think there's anything in that. So let's go ahead and put things in it. Let me do sudo and then vim. And it asked me for my password, of course. I'm going to type in I for include, and then I'm going to say dog, dogs, pug. And I'm going to press escape, WQ for finishing writing on that. And I'm going to look at utilize the diff command for the different files, for the two different files. So I'm going to say, let me just go back to this. I'm going to say diff, and then down, and you can see me using the upper and lower keys to save on typing. So I'm going to say diff for this file, my file 2, and you can see, and you saw me adding the different things to my file 2, and then we can say downloads my dir, my file 3.txt. Now you can see me, I just wanted to review the fact that all I have to do is type in my file and then the number 3, and I press tab and it auto completes. And what does it say? It's going to this is the difference between the two files. So you can analyze that on your own. Now in this example, let's say we had a very long file. So here we're going to stream etsy/password. And if we actually just list out the files in Etsy, there's all the files. But what we want to do is we want to stream the password file. Of course, we're going to use head, but I want to show you what happens when we use the cat command to stream everything. We can see there's a lot of information that goes beyond the screen. So instead of using cat, let's use the head command. And we can press return, and we can see that it gives us only the top portion of it. Now, if we use the man command, man head, we can show you it by default, it outputs only the first part of the files. So if we want a certain amount of files that it puts out, we can say -n and say the number 5, and this way it only gives us the first 5 lines. If we wanted to output the first 8 lines, for example, here is the first 8 lines. Now, there is another command that is kind of like head, and as you would guess by the PowerPoint slide, it's actually called tail, and tail gives us the last portion of the file that we're streaming. So if we said tail -n4, that literally gives us the last 4 lines of the file. Now, the thing I wanted to tell you is that the advantages of head and tail is, for example, a business case or usage case of head and tail is log files. So if you're running, like, for example, a web server, and you wanted to engage with a log file, you could cat it out, or you can even use grep or whatever stream that you wanted to use. It would give you like a cacophony of information, almost too much. But for a log file, you just want the first or the last, say, 20 events. So the head command is would be great for something like that. So you'd say head space dash n space slash space and then the number 20. So in the using the head, it would be n and then you would say 20 here, and that gives you the first. Actually, in this case, it prints them all out. But if you just wanted the first, say, 10 lines of a very long log file, here's what you would do: head dash n space 10 and then the and then the path to the file. And notice in this case we used the actual path, not the relative path. Let's quickly examine the contents of this file. myfile3.txt is within the mydir directory, and that is part of the downloads directory. And we're going to use cat to stream the file. There's only like 4 lines, so it's not a big deal. Incidentally, we can use the head command, and that, of course, is going to do the same thing, but we can say n2. And that would only give us the first two item lines, I guess you could say. But let's get back to cat, in which it does the whole thing. The only thing is that if by chance we actually fasten or made the file like this, so let's go back to sudo vim and let's just edit this file. And then I'm going to go include, and I'm going to say, instead of dogs and cats, I'm going to say albino, and I'm going to go to right quit, and let's cat this out, and we have albino at the bottom here. Now, what if by chance, let me type in clear again, what if by chance we wanted to sort that output? We can say, instead of saying cat, another way to stream it is the sort command, S-O-R-T, and if we press enter, it sorts it alphabetically. Now let's say we wanted to sort it numerically, and we can go back to actually editing the file. Let me press I for insert, and let's say 2 and then 10 and then 1 and then 2, and then 4. So we added some numbers to the lines, and just for formatting purposes, let's just have a space between the number and the letter. So now, instead of saying sort, we can use the dash n, or flag n, or something like that, whatever you want to call the dash. And then that will sort it numerically like this. Okay, we'll talk about the directories in a few moments, but the ls, whenever you run, for example, the ls command, what it does is, I'm going to press enter because we're going to run the command echo and then path, because this will actually echo or print the path that your computer uses to search for any of the commands that you run, including the ls command. So when we type in ls, what it does, and press return, what it does is it recognizes that that is actually the name of a program, and ls as a program is located somewhere within this path, and the path is separated by colons. So if you did a search for user local bin or user bin or just user local games or user games, it's going to be somewhere in there, and it could be in several places. So by default, it will use the very first matching command. You can actually add to the path in case you wanted to have your own private reservoir, And of course, but that's beyond this class. I would never want anybody in this course to do something that destructive. We won't be needing to do that in this class, but I just wanted to give you a quick overview of the path command. All right, let's take a look at the PS command. Now, the PS shows the running processes, all right, and it has certain fields. So let me type in PS. This is just a basic listing. So we start from left to right. The PID is the process ID, and the TTY is the terminal device where the process is running. And we have the status. Well, there should be the status right there. It doesn't really show the status. We have the time. That's the amount of CPU time in minutes and seconds that the process has used so far. And the next is the essential parts of the command that was used to create the process. So, for example, just the other time I used top. Now, top is an alternative to PS. So if I type in top, it has by default, it shows all of the owners or all the people that have been logged in, including root, that have been doing processes. So let me quit this and let me once again run PS, and this time I'm going to use a couple of switches right here, AXUW, and that gives a lot of detailed information. So what I'm going to do is I'm going to go to activities, and I don't even know if you see this. I should, let me just do this. Let me just do that. All right, so I'm going to run Firefox right here. As you can see, I'm running Firefox. And I'm going to redo PS with the AXUW. And if you want to know what these switches are for the PS command, just do man PS, and they will show you what all of this is. And I'm going to press enter, and then you can see that you should be able to see Firefox right here. So those are new processes that weren't there before. We have process 6174 and whatnot. And again, to run, this is the command essentially. Now, when I say command, I just double clicked on the icon, but double clicking it on the icon essentially resolves to this command right here. So that's the PS. This is the PS command in a nutshell. Okay, let's do present working directory, PWD, and that gives us as I said, the present working directory. Now, if we change directory and I said downloads and then my dir and press enter, if I said PWD, we can see that it prints out the actual directory that we are in, and it presents and it tells us the actual directory. Not the precise path, not the relative path. Now we're going to utilize the file command. So we'll do ls, and we have the different files here. So we'll say file and then myfile3.txt, and it shows it is of type ASCII text. So what the file command does is it actually tells you the type of file that it is. Let's use our change directory command really quick. So we're going to go back to downloads and then my dir, and I'm going to press enter. We can use PWD to verify that this is where we are in the file system. Now, the reason why I'm doing it like this is I want to show you a shortcut, because most of the commands I've been running is from the home directory. So a shortcut to get back to your home directory is change directory or CD. And I'm going to press enter. Now we can see, we can run the present working directory command to verify that we are in fact in the home directory. Now we're going to demonstrate the ever important find command. And I said it will, or it may be one of your most vital commands, because, it's no wonder that with ever, increasing file directories, the ability to find one single file is like finding a needle in a haystack. So we can use the find command. So let's say, for example, let's take a look at our downloads and then my dir directory. Let's say we want to look for my file 44, and we weren't sure where it was, but we know two things. It has the number 44 in the file name, and it might be somewhere in the downloads folder. So we can use the find command, and we can actually do man find, and this actually, it says search for files in a directory hierarchy. That's the man installation right there. So we can use find, and first thing we have to do is we have to specify the directory. So we know in this scenario that it's in downloads. Next thing, we have to specify the file name. So that is -name, and we know it contains the number 44, but we don't know if there's anything before or after. If I press enter, it's not going to find anything. It's not going to print anything. But if I do the wildcard symbols before and after, guess what? Voila! We have downloads, my dir, my file 44. Now, what if we wanted to look at the number, any file with the number 44 in it, but we wanted to search the whole computer? We can say find, and then this is the root, and technically we are under the root, as is everything under our computer. So get ready for a lot of output right here, and we can see that we get so many files with the number 44. It actually says permission denied. And so let's do clear, and let's say we wanted to find anything with the term my file in it, and we can see that it comes with a lot of different things. So we're going to run clear here, and what if we said downloads and the name my file? It's going to come up with all of them right there. And if I just said, instead of my file, let's just do the number 3, it only comes, well, it should have come up with at least my dir 3. Let's say my file 3, and it does come up with downloads, my dir, my file 3. And again, let's see, my file 2, and here we have my file 2. So that is the find command in a nutshell.